If you have questions, drop those in the comments as well, and we will get kicked off here. It's 1:31 my time, or as far as my watch is concerned. So, Keith, if you're ready, we can jump off. Ready to do this thing?
Yeah, can you hear me?
I can hear you just fine. Perfect.
Okay, great.
So again, today's conversation is on the use of expanding polyurethane grout for deep soil stabilization, specifically in reference to a project here in Arizona on the Loop 101. Keith, you're the engineer on the project. Why don't you give us a little bit of a background on yourself and maybe your introduction to the use of expanding polyurethane grout?
I've been a geotech engineer here in Phoenix for about 32 years. Worked originally with SHB, a small firm. Eventually became Agra, which eventually became AMEC. I left there in '99 to start a group at DMJM, which became AECOM. I was there for 11 years and ran that group. Then I went over to Kleinfelder, was there for about 5 years in Tempe, and they decided to close our office. So I went out on my own, actually met up with Sergio Aleden, who's the owner of Ethos, and I run a one-man geotech group over there currently, looking to expand, but just waiting for more work to roll in the door. So I've been involved with polyurethane and cement grout for several years. I can't even remember the first time I ran into the polyurethane. Probably, I think fixing some of the ramps on the I-10 freeway. There was a design build that built the what's called the park deck tunnel along with several miles of freeway in downtown Phoenix, and I think it was either the Eagle Lift or the Eurotech guys came out and did a demonstration, and then I've been using it ever since. I really like the stuff. We'll get more into that, but I definitely have a good history with using it and have used it on several deep foundation projects over the years.
Very cool. Very cool. Yeah, and my name's Brendan Allen Barrett. I'm the rep for Eagle Lift, which is the Eurotech affiliate in Arizona, California, and Nevada. I'm based here in Scottsdale. I believe this is our second project, Keith, that we've had a chance to work on together. I think the first one was the light rail here in Phoenix. But yeah, your time with polyurethane grout goes well beyond my own. So I've been servicing the area of Arizona, and I get into California and Nevada on occasion, not so much anymore. But since about 2012 with Eagle Lift, and I've been in Arizona since 2013, doing projects for public agencies, anything regarding lifting, leveling, deep densification of soil, lifting, leveling structures for the public agencies, private property owners, etc. But yeah, let's jump into this guy. You want to give us an idea of where we're at, Keith?
Yeah, sure. The project we're going to discuss here is it's a widening project of the 101 freeway that's out on the basically east side of Phoenix, Scottsdale. If you're familiar with this area, it's basically our eastern border where we have residential development on the west side and primarily the is it Salt River? Pima Indian community on the east. A lot of the bridges out in this area were built several years prior to the freeway actually being constructed. And so a lot of these bridges kind of just sat out there in farm fields for years before they actually connected it with travel lanes. This is one of those bridges. It sits over the Arizona Canal. We have thousands of miles of irrigation canals, it seems like, throughout Phoenix. This is just one of them. And we also have a kind of an issue out here where a lot of our bridge approach fills as they come up to abutments. There's a definite bump in the road. And what's what's often happened is that our backfills on the bridge approaches they weren't historically controlled in terms of moisture content when they were constructed, and so they may have been just compacted in. They were compacted to 95 or 100%, but moisture control wasn't key back in the day, and a lot of these have gotten wet since for various reasons, and we've had settlement at these approaches. This is just one of those, and so what we had here was we were adding an outside general purpose lane to each northbound and southbound on the freeway. And so you can imagine you're constructing a new lane at a certain profile, and you get up to this bridge approach, and there's a 3 to 4 inch bump in the pavement. So now your new profile doesn't match the existing profile. So what do? We need to fix the existing profile. Here at the and we only addressed really the northbound bridge approach to this bridge. The other 3 corners basically have all had issues. I believe, was it Eurotech or Eagle Lift was out there and possibly did some work on was it the southbound approach?
The southbound lanes, yeah, that was probably 2014.
Okay. Yeah, so here we had a bump in the road of about 4 inches that we needed to deal with. Obviously, it's soft there, so this basically impacted all of the northbound lanes, including the shoulders. We had 3 general purpose lanes, an HOV lane to the inside, and the outside shoulder. Some profiling was done along the bridge itself to see kind of where it sat. This isn't a very good picture, but you can kind of see where if you're approaching the bridge from the south, heading north, up stationing, you can see where that bump kind of develops at about 535, 70 or 80. It's kind of a max there, and then it picks the profile picks back up and eventually matches the I believe it's the approach slab to the bridge, which maybe I think it's towards 537 or so. It's been a little while since we've actually done this project now, so I'm not quite clear on all the details, but that's definitely the bump that we had to deal with.
So why don't we go back to your first involvement with the project and when this, the existing lanes became identified as having a dip and how that would impact the new lanes.
Yeah. What we did there was our investigation for the general purpose lanes, which were being built to the outside, revealed to us that, we had this issue, sent out a couple emails to ADOT, said, hey, what do you want to do with this? It really wasn't in our scope or the prime designer scope. In this case, it was URS to actually address what was going on within the existing lanes. However, obviously, you need to be able to tie it all together. And so what they decided to do was make this a post-design remediation. And so Pulice construction was already out on the job building the road. They added it basically into their scope to determine, what we should do there. And so I don't know exactly who had WTI come out, but Western Technologies went out and drilled a couple holes. That may have been done directly for Pulice. We had existing borings out there that we had done for the geotech investigation on the GP widening. So we had a fair bit of geotech information available right there. We sat down and discussed what our viable options might be. Certainly if you wanted to really take care of it, you dig it all out and put it back in. That's one way to address it. We decided, obviously, in trying to keep the road open, that wasn't going to be possible at all. The 101 freeway is a very busy freeway. just not able to shut that down for any extended lengths. The detours around there were, gravel roads to the east, and kind of city streets that would be way overloaded to the west. Should we go with that option of having to put in a detour? And so then we were looking at, what we might also be able to do. Polyurethane grout was always in the back of my mind, and certainly cement grouting, pressure grouting is another way to go. What we discovered there, I can show you, just talk about this slide here. There's embankment fill to a depth of about 30 feet, soft compressible clay within this from about 5 to 25 feet. The blow counts were anywhere from 3 to 25. Yeah, here's a couple of logs. You can't really see them, but the the red circled ones are where we have very low blow counts. These are the Kleinfelder wall borings. I think it's
where are these guys on the
these
boring?
these are the red borings. Looking at this, our approach is off the right side of the bridge, and so if you can see that KW18A in red, it's on the top. That's one of the two borings. KW19 is just right there, and so two of those logs are from that. The WTI borings, Western Tech borings, are the two that are labeled in blue.
They're the blue ones, yeah.
Yes, right. And so they were drilled right in the dip, targeting the soft, material that we had right there. Our borings were drilled for retaining walls along the south side, or the west side there. Actually, east is up on this sheet, and then KW18A was also a wall boring, and so we really weren't at the time targeting this issue. And so, yeah, between the boring and the other black borings that are there, those are the original borings that were done at the base when this was just farm field. So we couldn't really use those other than to get an idea of what was going on underneath, the area where we're having settlement. And the soils at those depths actually look pretty good. So the red are really indicators of bad conditions. We've got bad conditions on that first boring from 10 to 25 feet. And then the other one shows it's softing in at 5 and 20 feet. And then the other two logs, which are maybe a little easier to read, those are all R values, not R values, those are ring samples. You convert those to SPTs and you get values anywhere from about 3 to 11. So, they're pretty soft. Again, I think this material was probably put in fairly dry, got wet at some point, and just lost its strength. And so this is really the zone that we were really dealing with, is primarily from about 10 to maybe 25 feet. Again, looking at this, then we could consider over excavation, pressure grouting, polyurethane foam injection. I touched on over X. Pressure grouting with cement. The only reason I tend to lean away from this on embankment fills, only due to the fact that you're adding a lot of weight to an embankment when you use cement. Unless you get basically your pressure bulbs stacked on one another, you're going to have gaps in between where the weight of that grout is going to tend to want to collapse on the next bulb, basically. And so if you have a bunch of independent bulbs within the field or within the fill, with any one particular hole, these bulbs, which are heavy, are going to want to consolidate onto one another. And so I've always tried to avoid that by going with something lighter. Now, obviously, polyurethane is very light, extremely light, and the other great thing I really like about it is that it's a closed cell composition. It doesn't basically take on water once it's injected. you can cut a cross section through it and it might look like a sponge, but it's with a closed cell, it's really not letting any water get within it. And so it's not gaining weight over time. It's just basically, it finds its way into voids. And believe me, there were a lot of voids out there. We pumped a lot of grout, but you can go into that later.
Were there any concerns from ADOT or police when you approached them with the idea for a polyurethane grout versus a cementitious grout?
Boy, I don't really recall that there were any extreme concerns. Obviously, they've got some history with it. They haven't done a lot of deep injection that I'm aware of. I've done it on 3 or 4 projects, all with ADOT, but you get with different groups of people there, and you know, they've all got different histories. So no, well, I didn't really gather that they had terrible concerns. Did you?
Well, I don't know if Jonathan from ADOT made it in, but there seems to be a disconnect between maintenance operations over at ADOT and contracts and specs and, you know, some of the folks working on the construction side of ADOT, because we've been servicing on-calls for the last 15 years with maintenance and operations, and I've been a part of that process for the last 4 years, and it's always been deep injection. A lot of the smaller scopes of work like this, abutment slabs and things of that nature, we are going to 10, 12 feet based on penetration testing to not only lift the pavement, but densify the embankment fill long term so that this thing doesn't subside again, because that's certainly been an issue in the past, going out to locations that have been injected prior, either by in this case Urotech USA, or by, there's another polyurethane grout contract within ADOT that is just shallow injection, and so they have issues lifting flexible pavement AC. They have issues, lifting it and seeing it lifted long term. So we've inherited some of those projects by being able to go deeper with the deep injection process. At what point, because this is something that you brought up to ADOT, police, whoever, relatively early on in the project, but they were already paving by the time we were starting to talk change orders or scheduling, at least. What pushed the envelope there? What pushed the conversation?
Really, it was timing. A lot of what you guys can do is very fast. You can get in there and you're not tearing up lanes. Pressure grouting is something that takes a bit longer to do. They get setup times, wait times. You're injecting a very small diameter. Is it 5/8 inch rods?
5/8 of an inch, 3/4 of an inch. Yeah.
Yeah. So, the speed at which you can do, I think you inject it and it's pretty well set up within the next, 15 to 30 minutes?
Yeah, within 15 to 20 minutes. In most cases, we're at 90 to 100% full cure strength. There's variation to that, of course, depending on the circumstance, but that's pretty typical. I know a lot of the concern with ultimately the detour issue, right? Of some of these other alternatives were concerns when we were scheduling. And then we were also in a relatively, it's a freeway. It's a busy area of Scottsdale. You've got the casino. You've got Salt River Fields right there. Summer holidays. We were working right up to, we were out there starting in May. And I think we even got close to 4th of July between
spring training and.
Mm-hmm. Oh yeah. All kinds of fun stuff to deal with.
So I think what you guys did was you did all your work at night.
All the work at night. We had about 2 lanes to work in at a time, plus a safety lane, depending on which 2 lanes we were working on. But yeah, I mean, this graphic shows kind of the idea of what we're trying to accomplish. For those who aren't familiar with expanding polyurethane grout, it's a material that starts out, we use a two-part polyurethane foaming system. So it starts out as two liquid components. When introduced to one another, the reaction between those components is an expansion. So the material used for this project had the opportunity to permeate through more granular soils first, and then as it started to expand, that expansion is what would cause the displacement, compaction, further densification of the embankment here. And as you continue to compact, you're building confining pressures, and ultimately, as those confining pressures build, eventually the path of least resistance becomes the load of the pavement. And so in those shallower depths, you're actually able to accomplish lifting of the pavement, which we were able to do in this case. We were able to lift it. I don't know if we did a full 4 inches, but at least 3.5.
Yeah, I think you maybe ran into somewhat a limiting factor on that inside median barrier where you couldn't lift it too far because it actually began to crack. I don't think you damaged it, but they didn't want to lift it any further. Is that right?
Yeah. When you've got, I mean, ultimately, when you're lifting a pavement or a foundation, if there are areas that you don't want to lift, that's going to impact how much you can lift elsewhere, because you kind of have to taper it then, right? On this project, we had all of the northbound lanes about 120 feet beyond the south edge of the anchor slab. So we're 4 or 5 lanes wide, 120 center lane feet. And then we also supplemented the borings with DCPs. Can you explain how you picked some of those locations for the DCPs, Keith?
Those were random. No, actually, what we did was we looked at the profile, and we could see where that profile was dropping off, where it shouldn't be, and so we determined we had to go back about 120 feet. We didn't have a whole lot of geotech info back that far, other than the wall borings, which were kind of along the side. And so what we did was, within this area, we used the DCP, which basically is it's almost what we used to use on drill rigs. We'd call a bullnose sampler, where we would just drive a steel rod down into the ground and read continuous blow counts.
So for those who aren't familiar, DCP, dynamic cone penetrometer, I'll get to a little bit more detail on that as to the model that we use and some of the specs on that. But basically, it's a penetration test to supplement the penetration test from the auger borings that you had.
Yeah, and so we use that basically to come up with basically set our limits on what we wanted to inject, and then we further refined that later as they were driving the rods themselves to kind of come up with what we wanted. And then we knew we had to go deeper right near the abutments, and so I believe some of that you pre-drilled. And you'll talk about that, but it was actually kind of a layer maybe where we weren't necessarily able to get down through it with the DCP, but we knew we had something soft down below, and so we also concentrated on that a bit. Yeah,
so with a lot of the projects that we do, it's very common that everything can be brought in. We drill, what people refer to as penny-sized holes through pavement and foundations to do this injection process. Inject both the A and the B components of the polyurethane foaming system, and that's relatively non-invasive, by comparison of over excavation and having to repave, or larger cores for other forms of grouting, right? In this case, we were going so deep that the handheld drills that we use, the handheld hammer drills that we use to pilot holes for the injection pipes, as well as drive the injection pipes to depth, it wasn't enough. We were building so much skin friction on the injection pipes themselves that even if you could pilot a hole to 15 feet, you couldn't push the half-inch pipe through it. And so we were having to go with larger diameter holes. We ended up using a percussion drill mounted on the boom of a full-size excavator. I'll get to that here in a second, but I'll kind of step back to the dynamic cone penetrometer. That's Keith, his handsome self, there observing the penetration testing with the crew. The dynamic cone penetrometer, that's the device being held by the two men standing there. And similar to other forms of penetration testing, we're measuring blow counts. And in this case, we use a Pagani, so that utilizes 35.5 millimeter diameter cones. On top of that sacrificial cone is placed a 20 millimeter diameter rod, and a hammer, about 66 pounds, is dropped on top of that repeatedly from a free fall height of 20 centimeters. And that's driven by an electric motor as opposed to being lifted and let go of by hand, which is typical of other dynamic cone penetrometers. So the 60-pound hammer does give us the ability to make it through tighter soils, some gravel, different forms of aggregate. I've even seen it break through smaller cobbles. So where you might be getting 50, 60 blows, which would be really high, and then it breaks that cobble and drops a foot because that cobble is in loose soil, right? In this project, again, we, under the direction of Keith, did DCPs throughout the area, kind of within, towards the center of the drive lanes. And as you're closer to the bridge, rather, so here we've got 23 linear feet from the bridge, 58 linear feet from the bridge. Those deeper soils, we're seeing single-digit blow counts. That's what you see highlighted in orange. And ideally, using this 66-pound hammer, we're looking for 10 blows for 10 centimeters of travel. The DCP rods are marked every 10 centimeters. There's an engraved ring on the rod, and we're, again, just measuring blows of that hammer. And, the more blows it takes for that rod to travel 10 centimeters, the more dense and likely the greater load bearing capacity that soil is going to have. If it travels a full 10 centimeters in one blow, that's very loose soil, or possibly, a void. In some of these cases, I don't have them here. Some of these single blow counts, that's not even really a full blow. That's that's the weight of the hammer. So it was just sliding 10 centimeters at a time into the embankment. But here you can see with these guys, as we got farther away from the bridge, the soils were getting tighter and tighter. Still some single-digit blow counts, but in the more shallow soils. And that actually helped us change the allocation of the material that was quoted. This project was quoted and invoiced based on a force account basis. So what material was used was actually invoiced. And because that was the case, and because we saw that as we were getting farther away from the bridge, it was, not so much the deeper soils that were an issue anymore, we could reallocate that material that would have been used for 4 depths, 5 depths of injection to closer to the bridge rather than farther away from the bridge. Like I mentioned earlier, for this process, typically what people like to see are these pictures here on the left. We're using a 1/2-inch injection pipe, so we've got to drill a 5/8 inch diameter hole, a little bit larger maybe, to advance that pipe through the soil, and all that can typically be done with the handheld hammer drill like you see the crew using here. But what we were finding is that even with single-digit blow counts in some cases, so really loose soil that we were driving into, that half-inch tubing was building so much skin friction as you drove it deeper and deeper into the ground that it was too much for a full-grown man to lean on a drill and actually advance it to the depths that we were looking for. In this project, closer towards the bridge, we were trying to densify soils at 30 feet. So our longest injection pipe was actually advanced to 25 feet. And again, with that skin friction, we weren't able to advance those pipes to the full depth that we needed to reach to densify that problematic soil at 30 feet. And so we brought in the percussion drill mounted on the skid steer or the excavator here. And through that, we were able to pilot roughly 3.5, 4-inch holes, I think they were, and drop a full cluster of injection pipes rather than doing individual injection pipes. I'm going to go back here just a second to kind of go into a little bit more detail on this process. I've kind of described the material that's used, but in order to uniformly densify the soils, what we have to do is inject at multiple depths. Unlike what's more common with other forms of compaction grouting, displacement grouting, jet grouting, instead of drilling to the full depth of the issue and pulling our pipes out as we inject, we place multiple pipes at varying depth intervals, because from the tip of our injection pipe, we only expect to influence soil within the first 3 feet. So with cementitious grouting, you're trying to create bulbs. We're trying to create zones of influence. And because our material starts out as a liquid, it's going to travel the path of least resistance and then expand and push loose material into more dense material. And, as those confining pressures, start to give you uplift or bump at the surface, because it's only going to travel so far and influence so much soil from each injection pipe, we actually have to stack those injections. And so on a project like this, we were spacing our injection pipes on 4-foot centers throughout the area of concern. And again, we were the full width of the lanes, and 120 center lane feet long was our project area. And so throughout there, we have to drill holes for our injection pipes every 4 feet in, lengthwise and widthwise. And because we were going so deep and building that skin friction, instead of drilling individual holes, we drilled single holes and dropped a cluster of 5, 10, 15, 20, 25, 5 plus tubes. I think we actually added more than 5 just in case tubes got clogged. But we dropped all of those tubes to depth at once, and then came back and did our injection. The nice thing about even having to drill larger holes was that they were still small enough that during daylight hours, these lanes were drivable. So that was huge. Yes, we were closing 2 to 3 lanes at a time at night for a 6-hour shift, right? But during the day, during peak traffic hours, those lanes were just as drivable as they were before we even started. How about project wins, Keith?
Project wins. Well, here, certainly it fixed the problem. I think I know you guys injected a lot of foam. So there must, there's certainly voids down there. There's certainly loose soils that we know that the polyurethane was penetrating. I think as you inject your foam, you do it from top down, right?
Typically, yes. Yeah. So because the material is expansive, right, and expandable up to 20 times its liquid volume, typically, I mean, for the foams that the grades of material that we use for lifting, it's typically expandable up to 20 times its liquid volume. But under confining pressures, it's not going to expand, so under the load of the road, underneath the confining pressures of the soils it's being injected into, it's not going to expand its full 20 times. So what might free rise, so under known confining pressures, if we were to shoot it out on a table or on the floor, rise 20 times, what might start out as a 4-pound polymer or a 3-pound polymer, a material that's, 3 or 4 pounds per cubic foot in that free rise condition, might actually cure closer to 10, 12 pounds per cubic foot because of its further densification. But sorry to cut you off, Keith.
No, but that's fine. And even under that condition, 10 to 12 pounds, that's nothing compared to the unit weight of the soil, comparing it to a cement grout that's even heavier than that. And so yeah, I think that's certainly a win. It was obviously a win being able to keep a couple lanes of freeway open at night and then keeping everything open during the day. That was definitely, I drive that. I used to drive that every day. I just moved. But, it was a pain, when that's freeway shut down. So
yeah.
That was certainly a win. I'd recommend it certainly again. I would do the exact same thing again, for this project. So
I'm circling back to some of the questions in the chat, and guys, if you have guys, gals, whoever's tuning in, there's quite a few of you now, 14. Let us know what questions you have. I know Mo had some hesitation or some reservations on using the material. What is his question specifically? Likes advantages over Portland cement grouting and especially more effective at lifting, but still have reservation about proving the concept for deep stabilization. And then we have some questions about what is considered deep injection. So the process that we use, and I mean, there's different processes for different types of work. If we were just out to lift a slab rather than densify soil that still had a potential to consolidate, we might simply drill through that slab, drill a 5/8 inch hole and put our injector tip in that hole. So we're not using an injection pipe, and then inject the material. And those two components, the A and the B, they're being introduced as they go through that hole in the slab or in the pavement, and the material is getting out into the soil, traveling path of least resistance, expanding. If there is soil to densify, it's densifying it, and then you get your lift. And that'll typically densify soil from grade to 3 feet below grade and maybe even 5 feet below grade, depending on the conditions. If we have more than 5 feet of soil that has a potential to consolidate and contribute to further settlement of that structure, of that pavement, then we have to use that injection pipe and start stacking our injections. And anytime we use an injection pipe, that's what we consider deep injection. Mo, I don't know if you have any more questions. If there's anything about the reservations that you had or the concerns that you had that we haven't answered yet, please drop that stuff in the comments.
One thing I wanted to say is, I think as you go deeper sometimes, maybe if you're 20, 25 feet, 30 feet, you're often pre-drilling to get down to that depth, but are you changing the composition of your mix a bit to retard the setting?
We can, yeah. So like a 3 pound, 4 pound polymer, even if it in its least dense state, so not having the confining pressures, is going to have a compressive strength around 30, 40 PSI. And then you take that 3 pound, 4 pound polymer and you put it under the confining pressures of soil, the load of a structure, what have you, and it densifies to 10, 12 pounds per cubic foot. Its compressive strength is going to be way up, but that material reacts very quickly. And when we're lifting, we want it to react very quickly, right? Because we want to be able to lift something, but also not overlift it. We don't want it to start lifting and the material keep going and keep lifting after we've reached the highest practical elevation or the intended elevation of that pavement or that foundation. To get deeper, if we use one of those really fast reacting materials, it might not reach 20 feet. It might not reach 30 feet, right? It'll start expanding in the pipe and never ever make it into the soil. So because we're relying on a chemical reaction, we can impact chemical reactions by controlling temperature. When we want a material to react very quickly, we can heat the material to 100, 120 degrees. If we don't want it to react very quickly, we can not heat the material. We have heat, the trucks are equipped with heaters to impact that aspect of the chemical reaction. But then we also do have different grades of material, higher density materials, even when, the least dense materials, those faster reacting polymers would be dense enough to carry the loads of most structures. We use higher density materials, not because we need loader or greater load bearing capacity from a denser material, but actually because it reacts less quickly. It reacts slowly, which allows it to get to that depth and then actually get into the soil before it starts to take place. As far as when the chemical reaction takes place, because I saw that question come in, it depends on which grade of polymer we're using and what it's heated to. So if we inject, if we're trying to lift something and we're injecting into the first couple of feet of soil or just beneath that pavement or that foundation, it's going to go from its liquid state to foaming. So it's going to start foaming in a matter of seconds, and then it's going to stop foaming within another 3 to 5 seconds. And then you're going through that cure cycle, right? Of that we like to talk about being, 15 to 20 minutes hitting 90 to 100% of your full compressive strength. If we're trying to get super deep, right, we're going to use more slowly reacting polymer, or we're going to impact the reaction so that it takes place more slowly, again, for all the reasons that we've described already. I know, and I think I got off on a tangent, Keith, when you asked your question about do we start at the bottom or do we start at the top? Typically, and it depends again on the project and the foreman and what he finds to work the best, but typically we're starting with the most shallow injections first, injecting, densifying that zone, again, from the tip of the injection pipe. We only expect to influence soils within 3 feet of the bottom of that injection pipe. So, if we're injecting 2, 3 feet, we're stabilizing or densifying soil to -6 feet and all the way back up to, the pavement. But we do that to, densify that zone of soil rather than injecting at 30 feet, having to densify all the soil above it before you get potentially a bump at the surface. Because doing so, having all of that additional weight on top of the material that isn't densified would use a lot more material, because again, it's not a static material. It's a material that can be further densified, right, under confining loads. And when that happens, we'd end up using more material, which is invoiced by the unit, because this work is billed on a force account basis. We'd end up blowing through our budget, maybe not accomplishing what we were out there to accomplish, or at least doing it, but making it a lot more expensive to the owner, to the client. All right. Scrolling through the chat. I don't know if anybody else has any more questions. We still have about 10, 15 minutes if anybody does have questions. But this is the contact information for myself and Keith. If you think of a question later today or tomorrow, you can, of course, shoot us both an email, give us a call. I'm happy to answer those questions to the best of our ability. Other than that, when does the reaction occur? Got that question done. I don't know. Any final thoughts, Keith?
No, not really. Like I say, I've used this, I know, at least on 3 or 4 bridge approaches where the fills were 25, 30 feet, and it's worked very well on every one, and I'll keep on doing it.
Awesome. That's what we like to hear. Yeah. So for those who don't know, Ethos is an engineering firm. What are the range of services that Ethos provides? You're the one-man band as far as geotech goes, right?
Yeah, we're small. We're a DBE here in Tempe. Primarily, the owner is a structural engineer. His son's a roadway slash structural, and he has another structural engineer working for him. So it's primarily structural with a geotech component right now.
Very cool. What are some of the projects that you guys are just wrapping up now or working on actively?
I'm the lead geotech engineer on the South Mountain Freeway project that's being built here in Phoenix. It's 22 miles of new freeway. I think there's 60 bridges on it. MSE walls up the yin yang. It's over varied terrain. Some of it's in rock, some of it's on soft clay. You know, it's I guess it's ADOT's biggest project that they've ever put out. So trying to stay busy with that and looking for work is what I'm doing.
Aren't we all? Aren't we all? We got a couple of more questions in. Thanks for stopping by, Jason. It was good to see you in here. What is the typical compressive strength? Again, that is going to vary based on the material that we use and the confining pressures of this scenario, the load of the structure that we're trying to stabilize or lift. So free blown, a 3 pound, 4 pound polymer's probably got 3 pounds, 4 pounds per cubic foot, that density. It's going to have a compressive strength around 30, 40 PSI. But then when it further densifies to 10, 12 pounds per cubic foot, the density is going to be closer to 200 PSI. So again, it depends on what material we're using. You know, I'm quoting some of our least dense materials, but it also depends on the load of the structure. If we're trying to lift, a silo, which is, polyurethane grouts have been used to lift settling silos and densify that soil. We could accomplish the densification, densify the soil enough to mitigate future settlement of that silo. But because the load is so concentrated, it's going to take a lot of material to, because the material is going to densify under that load, it's going to take a lot more material to actually lift it with polyurethane grout alone. Now, Eagle Lift is a general engineering contractor. We do the polyurethane grout injection. We're the licensees for the deep injection, the patented deep injection process throughout Arizona, California, Nevada. And we've been doing that work since 95, so over 20 years now. But in addition to that, we also do work with push piles, helical anchors. So we have different tools in the tool belt to lift structures when either they can't be lifted by polyurethane grout injection alone, or maybe grout isn't the most cost-effective way of accomplishing the lift. We can, swap one technology for another or pair the technologies to find a solution that'll work for the client that we're working with. But yeah, if there are no more questions, I want to thank everybody for stopping by. We referenced Western Technologies earlier today and some of the drilling work and the boring logs that they put together for this project. I'm actually partnering with Western Technologies next week to do another webinar on the who, what, where, when, why of soils reporting, and why different services in different circumstances, and what to shop for, why to shop for it, and how to use your soils report should you find yourself needing to commission one. And that's coming next Wednesday at 2 p.m. Pacific time or Mountain Standard Time if you're here in Arizona. So that'll be myself, again, Brendan Allen Barrett with Western Technologies. And Keith, I want to thank you. If you don't have any final thoughts, thanks again for participating today.
Yeah, you bet. Thanks for having me.
Awesome. And again, this is our contact information. So if anybody watching, now or in the replay has questions, again, feel free to shoot either of us an email. That 815 number, that's my personal cell phone. So if you prefer text message, that's available too.